custodianship, GDPR, privacy, et cetera, et cetera. But in general, what it came down to was, how do I control access to the bits that constitute the business that I am conducting with other counterparties? Not just, and none of them were satisfied with the idea that cryptography was the answer. They wanted to limit access to the bits. So that means IPFS doesn't work if you do it in a public way. That means that they want to lock that stuff down. And if you're on a private blockchain, and it was a matter of emperor's clothes. We did sell a lot of it, but it's emperor's clothes. I'm saying it right now. I built the thing. I'm saying it. That private blockchain implementation was a shared database that we could have implemented much better in DB2 or Oracle or any other thing. And the only reason we did it with blockchain was because it was hugely good for press and for marketing. A grower of coffee beans saying, oh, I've got my coffee bean stuff on the blockchain. They're not saying that. What they're saying is that somebody from IBM called them up and said, I will put you on stage with Ginny Rometty in Las Vegas in front of 30,000 people and promote your coffee bean growing operation, because we're trying to promote the idea of blockchain. If you hold everything, if you made blockchain boring, if you took the word away, most of the companies that were doing those POCs would never have done them. So have I shocked everybody enough yet? All right, I'm seeing some chuckles. Now, while I was living in Australia, and actually a little bit before, a company I was working with had a really good phrase. I've always kept it since, but something doesn't work, but it would if. If you say that 5 times, but that won't work, but it would if. Oh, but that won't work. But it would if, right? If you say that 5 times, you'll have a wonderful new business or a patent or an invention out of it nearly every time. It's a great way of thinking about things. You don't shirk away from the problem and put on the emperor's clothes. You say, no, that doesn't make sense to me, but it would if this. So what makes sense about using blockchain if compartmentalization is essential to companies, which should be QED to everybody, right? I mean, who you don't want your business conduct, your business relationships, your transactions, most of them, to be known to your competitors. And as it turns out, in a cooperative world, most of those folks are going to be your competitor, or you're going to wish you hadn't shared that much information with them at any given time. And then the worst problem is any consortium's security perimeter is only as good as the stupidest admin in the consortium who has a full node or a peer, as we call them in Fabric, right? So, you say, well, it's private. Well, I've got, and this is a true story. I was working with a company working in trade finance, and they had set up a blockchain they were very proud of. And I said, well, where is it? And they said, well, it's on we have 4 nodes running. I said, oh, fascinating. Where are they? They said, well, they're on our server. And I said, wow, that's great. Have any of the 12 banks that you're working with asked if they could run one of those nodes for themselves? And they said, why, yes, they have. In fact, they all have. And I said, that's really good. Not everybody does that. A lot of people are fine for you to run them, which I find hilarious. But in fact, they wanted to. And I said, what happened? They said, well, the problem is none of them wanted any of the other banks to have a node, right? Because if they did, then they would have too much metadata or trace data, or maybe the data itself, about their customers, their banking customers' activities. It was not okay. Compartmentalization is easy in a centralized system. It's really hard in a decentralized blockchain system, and supremely hard. The farther away you go from, the farther you go towards tamper resistance and away from surveillance resistance, right? So when we think about, a lot of pointy-haired managers think about blockchain in terms of security. Oh, it's a more secure database. To a lot of them, that's what they're thinking. It's a more secure database, and it's cool, and it's called blockchain. Well, security is many things, but two big ones are surveillance resistance, data avoidance of data breaches, which is really what most CEOs are worried about. They're worried about their data getting out there to the people they don't want to see the data. They're not so much worried about tamper resistance. I have never in all of my experience found a CEO that was worried about their own people tampering with the data. In fact, they kind of like that. They want that flexibility. They just don't want other people tampering with it. Okay, so that's all the negative I have, and I promise I'm going to go positive, but that's the negative stuff. That I think Andreessen was right. That these private shared databases, there's utility in them. A colleague of mine over at Ernst & Young will tell you that he sees no utility in them. I'm not going to go that far. I think that shared databases are quite useful. My favorite one is GitHub. But you can have a shared database. And in fact, I think we'll return to sanity in the world of marketing when Arvind Krishnan, my old dotted line boss at IBM, renames IBM Blockchain IBM Cloud Shared Data Services. And I guarantee you that will in fact happen sooner or later, right? It's a wonderful business, because now as a cloud provider, we can sell you however many companies are in the consortium, we can sell that many times more amount of money for an implementation we could have just charged you once for in the SaaS environment. My final point about this is that in a SaaS, and if you're worried about security, well, IBM will solve that for you. They will put it in a big mainframe in secure. And I must ask then, if you could BaaS, right, a blockchain as a service, why not SaaS, right? If they're running it all for you, why not let them run it all for you? And then let the consortium have an admin and set up the JV that you're setting up anyway, and just call it blockchain, but build it on DB2, right? So you have good compartmentalization, you have good access controls, you can determine who's going to see what at what time. And if you were really worried about IBM or somebody else's admin, having root access to change the system without your knowledge, great, Shamir all the keys. Use Shamir Secure Sharing, share out all the keys, all the root access keys, so that 60% of the companies involved in the consortium have to turn their keys in order to make changes to the system. Now you've got all the benefits I described of blockchain with no blockchain. Right. So all the things that Tyler's talking about, those are all wonderful things. And that's something that I noticed in the speeches beforehand, was that nobody can argue with the need for transparency, with the need for better tracing, the need for track and trace, the need for the appalling nature for the last 50 years or more. Right, and the whole epoch of EDI has had problems with visibility, with coordination, with things as simple as revenue recognition, right? You've got a bunch of POs that are being calculated against a rate table, and a bunch of them come in all at the same time, all get calculated from the same base figure, and so you have incorrect discounting. And consequently, you have to spend 40 or 60 or 90 days waiting to actually, under generally accepted accounting principles, to recognize that revenue, and that causes all sorts of havoc in terms of delays in financing and all sorts of other things. These are all problems that are easily solved. They're not easily solved, actually, that's the point. These are hard problems, but they're straightforward, and we have for 50 years shirked our responsibility in every kind of industry to get our act together on it, spend the time, money, effort, and prioritization to do good security and good systems on just from human to ERP. And so we find the shiny object, blockchain, and we say that's going to solve it. It's not going to solve it, right? IoT is has some interesting solutions. Robotic process automation has some interesting solutions. Blockchain itself creates new problems, and constrained in this particular area, presents no solutions, except, here's where I'm going to go positive. What a public blockchain does for you is it gives you the closest thing we have to verified ordering and hash management. And for the propeller heads in the room, for the non-propeller heads in the room, I'm going to translate that. You need to know in any distributed system, including your iPhone, it knows this very well. It's got a bunch of different machines, and those different machines need to coordinate in a variety of ways. Usually they need to know something's got to happen before some other thing has to happen. And it's got to go right. And a process can't, unless it's, it has to be under rules for things like double execution or double counting or what have you. And usually we're doing this within a single, a machine or inside of a single company. And so you have middleware typically, or a bus inside of your machine that will handle the coordination of different machines that need to work together. Basic law of science in distributed systems is you have to have a common frame of reference. Peter, check my math on that. Am I right?
Sorry, I was just dealing with an incoming call at the critical moment.
All right. So, I never listened to me either, so it's fine.
No. I was listening to 90% of it, and then my phone was ringing, and I'm going, "What on earth is going on here?" But
well, I think I'm right about this. Anybody want to?
There are 23 other people on the call, though, so I'm sure that.
I'm so sorry, Peter. I didn't mean to call you out. Yeah, I mean, would anybody care to disagree with that? That in a distributed system with multiple machines, you have to have a common frame of reference if you want them to be able to interop or to work together without making a mess, right? Non-determinism, race conditions, blah, 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 right? So what do you use? You use a bus of some kind. You have a bulletin board, a message queue, or what have you. And you say, all right, I'm going to put these keys and these values on this bus. I'm going to pub sub. I'm going to do a much better job coordinating these machines. Well, in between companies, you can do the same thing. In fact, you must. And in your high volume businesses, or your business partners, if you're a big company and you're in, like if you're BHP Billiton or Rio Tinto, and you're working with your primary slurry company, you've got massive volumes. You have reasons to spend the millions of dollars that you're going to spend on a system integrator to get your ERP system and their ERP system working in harmony. And then you're going to do it again and again and again. And you're going to have silo after silo after silo, and they don't work together, right? So you say, oh, well, we need a common frame. We need a single point of truth for a bunch of different companies. Let's create a blockchain to do that. What have you done there? If it's a private blockchain, another silo. What happens when you run your rubber company or your rubber supply chain consortium blockchain, and it runs smack into the automotive industry supply chain blockchain? And now you have to stand on a bridge and brandish your swords and decide whose blockchain is going to prevail in this integration. And you're back to integrating things. That's a terrible idea. And that's, and I will talk about it in a second, what we're doing with Ernst & Young and a bunch of other companies. The head of blockchain over at Ernst & Young makes a very succinct point that, a company in the supply chain, says it gets a call from their wholesaler or somebody, a big supermarket chain like Walmart, and it says, hey, would you like to join our blockchain? And they're not really asking, right? What they're asking is, would you like to continue to sell your products through us, right? And so you say, sure, I don't know what that is, but sure, I'll be on your blockchain. And then your bank calls and says, would you like to be on our blockchain? Then your financier calls and would you like to be on our blockchain? And then your other wholesaler calls and says, would you like to be on our other different blockchain? And at some point, and this is the joke, you just say, just fax me the order, right? So how do we avoid this? We say, no, we're going to work not as a single point of truth mental model, but as a common frame of reference mental model, a consistency machine. If we could use the public blockchain as a consistency machine that knows effectively, and we can use a little bit of zero knowledge, not a lot, to effectively say, this piece of middleware called the mainnet can tell us that this record in my database and the record in your database are verifiably identical, and that the workflow steps preceding and following that, the deposition of that record, will operate along a continuity of a workflow with everybody maintaining consistency every step of the way. Without that piece of middleware, the mainnet, knowing anything really about what we're being consistent about, it just knows that we're consistent or we're not consistent. And if you use it, if you use the blockchain in that way, then you have opened up, you're doing less with it. You're not putting data on it. And in fact, that's my message. Don't use blockchains as databases. They're terrible databases, but they're really good middleware. And if this is shocking to you, that's my job today. That's my job today, is to shock you and to say, hey, we need to think differently about blockchain if we want to get over the mountains. The blockchain is middleware, and the job is ordering and hash management. I'm going to put hashes on. I'm going to do it cleverly in such a way that each proof, each hash, is a proof not of existence but of consistency. That your record, my record, and Sly's record, and Sandra's record are the same record verifiably, and that when we go to the next workflow step, say for example we have a master service agreement between us, and we're going to say that master service agreement is verifiably consistent between us, and that has a rate table in it. And now we're going to have purchase orders that are going to be calculating against it. Each one of those, the only thing that each purchase order and the MSA itself is simply a hash in a shield contract under zero knowledge, sitting on the mainnet that looks like noise to anybody but those of us who share the secret. I see at least a few people here that know a few things about zero knowledge, so I'll make this analogy. In zero knowledge, succinct zero knowledge, ZK snarks. A good way of talking about ZK snarks is to say, I have a secret, I'm going to prove to you that I have a secret without telling you what the secret is. This approach to blockchain, to mainnet, I would say is using a little bit of zero knowledge to do something slightly different. Now we're saying we have a secret. We all know what the secret is. And the thing that we're going to use to make sure that we have the same secret doesn't know anything about our secret. And anybody looking at it would just see noise or would see fuzz and would hear a metronome, tick, tick, tick. There's no information lost. And that methodology is what we call the baseline protocol. So that the last bit of my speech here is to say, almost exactly a year ago, Ernst & Young, Microsoft, and Consensus got together and started building something that has now become the baseline protocol. The baseline protocol is not a platform. It's not a platform, a product, a coin, a token, a scheme. It's none of those things. It's a standard technique for traditional systems of record like SAP, Oracle, Microsoft Dynamics, Sage, Mongo, any kind of state machine, to maintain consistency on a workflow step by workflow step basis with what we would call atomic compartmentalization, right? Every workflow step, Peter and Sandra and I can be in one workflow step, and then all of us can be in another workflow step, and everybody except Peter, Sandra, and I may have no knowledge about the previous workflow step. I'll give you an example of that. Say you are competing with Amazon. You make a Kindle knockoff or something like that. And you really you have to use them to ship your product for what they're buying up freight forwarders everywhere. So, and you need the delivery date from Amazon to calculate your invoice, right? Maybe you have in your invoice some business logic that says, I'll give you a discount if it's 2 days late for any reasons, including the shippers, right? I don't think anybody of us would want Amazon to know, and this is they do today, to be able to go into their personal database and figure out as much as they can about our volumes, who our customers are, when they're buying from us. They could do that today under the current regime. Wouldn't it be nice for them, short of opening up the box and seeing the larger box and seeing our logo, wouldn't it be nice if they could give us that delivery date, verifiably, we know it's for sure the correct date, without them knowing anything about us or our workflow. You can do that with a bulletin board, right? That's a classic loose coupling distributed system design. They dead drop it. They dead drop the date, and we come and pick it up. They don't see us pick it up. It's publish and subscribe. So using the mainnet for this very limited thing expands the utility of the mainnet to any business process, B2B business process automation workflow anywhere that requires compartmentalization in many different companies. And that's what the baseline protocol is all about. It is now 600 active members. It started with 14 companies, including AMD, BP, British Petroleum, Kaiser Permanente, and many others. And now it's 600 and growing fast. The GitHub repo is github.com/Ethereum. Well, I'll put it in chat later. It is a standard in development under the Oasis Open Standards body, which is a venerable standards organization. We're very proud to be in part of it. And now the job is to build the standard around the reference implementations that have been delivered. And I'll stop there.
All right. So thank you very much, John. Yeah, it's exciting to be part of Baseline. It sounds, I think we're going to do great things. So thank you.
Thanks, Peter. Yeah, we're excited. Please join us. You can. It doesn't cost a dime to be part of the Baseline Protocol community. If you want to be a sponsor, Oasis will be happy to pick your pocket and take your sponsorship money. But you could be a technical steering committee member. You can be a general steering committee member. You can be a maintainer. You can be a committer. You can have a big voice in how this, and this will, I think finally we have something we can apply without feeling like we were selling the emperor's clothes with blockchain, where blockchain is essential, definable, simple to understand, and doesn't require people to fundamentally throw out their previous way of thinking about security in their information system. This is CISO certified. So please join us, and we could use your help, and it's a really good opportunity. It's early days still, so it's a good opportunity to get in front of it and get some recognition, get some business. Thanks, Peter.
I think we've got time for just one quick question, and then any other questions should go on to the SCOBC channel. So are there any questions for John? Yeah, so yep, so that's, I think probably people are just speechless with so many, they've got so many thoughts and so many ideas, but they don't know what to ask first. So yeah, I'm sure we'll have questions for you later on. All right, thank you again, John.
I'll stick around. Thanks a lot, everybody. Cheers.
John, I'll just say that Baseline is so easy in retrospect. It's absolutely a brilliant concept. So well done. And thanks for the chat.
I will piss in Peter's pocket to say that none of this would have come up. We would not have gone on this road if Peter's work hadn't infected our thinking 2 years ago. And that's a true thing. So Peter, we're grateful to you.
Oh, thank you.
I have a question. Peter.
Can you hear me?
So the question is like a consortium, like merging integration of the two consortium. It's a good idea to have a group of companies to have like the list of transactions in an ordering fashion. So like he said, like a bunch of people calling me to join a different blockchains would be a ridiculous sort of thing. But is there any bypassing of this solution? Because it is to some extent of by far, it seems like a good idea, but except it has a big challenge that like he said, like many blockchain communities will keep asking me to join here and there. So if there is a procedure to a simplified merging of these blockchains to grow in a bigger, like for example, like a bigger consortium, like merging, if that challenge is achievable, is there any process or something like that?
Yes, Peter, may I on that? Yeah, so I'm glad you asked that question, because obviously I'm going off script and didn't do slides because I hate slides and everybody hates slides. So I did not, going extemporaneously, I missed a really important point, which is you want to have compartmentalization, but you want it to also have no silos, right? So what the baseline protocol allows you to do is take a series of workflow steps and instrument them almost entirely off chain, right? We're talking about SAP, Oracle, right? My SAP system, your Oracle system. And over time, we're hoping all of these systems are basically baseline compliant with the componentry required to run baselining. Today, you can just add them to it with non-destructively to your existing systems with an integration pattern. But as you do that, what you really want to be able to do is something that looks a lot more like a Slack work group than a consortium, right? Consortium are hard. I've been selling consortia for 30 years. They're hard. They usually take about 18 months just to get to the starting line. The negotiation is tough. What you want to be able to do is just start cobbling together counterparties into a flexible work group. And you can do that in the 1820 contract that's in the baseline system. But then the cool thing is you can say, look, I've got, hey, you bump into another workflow that's also living on the mainnet. Again, the only thing that's showing up there is a couple of a shield contract and a Merkle tree full of hashes, right? And you say, well, I tell you what, we want to integrate our workflow step 22 with your workflow step 33. And as long as those two steps have logical connectivity, right? Or maybe you have to run a translator, but as long as there's a reasonable reason to connect those two workflow steps, you can simply do it. You don't have to call a network administrator and argue about blockchains. All you have to do is make that integration, and you still can maintain compartmentalization of awareness, because the parties in the other workflow, if they're not part of that one workflow step, don't have to know anything about the parties in the other workflow, and it'll still work. So you have continuity, you have assured continuity and consistency step by step, but you don't have everybody in a digital nudist colony.
Okay, look, thank you, John. And I suggest maybe taking the conversation to the Slack channel, I think. But thank you very much for your answer. So our next, now we have the lightning talks, and obviously starting 10-minute lightning talk 7 minutes late, that would be really unfair if we say, hey, Atul, you've only got 3 minutes. That would be pretty unfair. So we're just going to shuffle everything along by about 8 minutes, which is okay. So our next speaker is Atul Patel. He is the co-founder of DLT Ledgers and is the vice chair of the Trade Finance Special Interest Group in Hyperledger Foundation. So I'll just share your slides.
Can you hear me okay? Peter, just wanted to check.
Yeah, I can hear you. So please take it away.
Perfect. Thank you so much, Peter, and good morning to everyone from Singapore. I would love to let me just make sure. Yeah, I got a 6-minute timer on. So I wanted to just talk to you about what's happening today in terms of supply chain, the gaps that you see specifically in the scenarios that we live in the world today, the new normal. So if you can go to the next slide, Peter, just wanted to give an example where I come from locally here in Singapore. Talk about, what has happened in the last 3-4 months. Singapore is a small representation of the world, but it is indeed a good representation of the world. So, we had, obviously something like closure to everyone had a circuit breaker here, and there was a definite casualty in the supplier in terms of the not able to understand what it would look like from a demand point of view. And 500,000 egg hatching hens in parts of Singapore. The sales plunged second week in month of May, and then I think they basically had to discard 250,000 imported egg, right? So I think it's imperative for you, if you are a large enterprise, to make sure the health of the supply chain is kept intact. So just to give you an example, there are various examples around the world in terms of how the financial health of your supply chain has been impacted during the pandemic. You can go to the next one for me, Peter. And it's really, how do you achieve what I call a financial resilience, right? So the financial resilience is actually you have to build your own supply network. Now, for years and years, people have built their supplier portals and supplier systems, and they have run out certain programs. So what is the difference here is that now you could actually look at the financial resilience, and you can back that into your paperwork that you are running through with your supplier portals kind of solutions that you may be having. So if you could, in some ways, make sure that with the help of distributed ledgers, provide this bit of linking up, if you will, between your suppliers, yourself, and your financial providers. And that's something I think would really give you an edge as a large enterprise to really take the financial resilience of your supply chain in your own hand. So that's the solution is called Supplier Financing Network. And that's something that is really, I think it can only be done in a distributed ledger type of a setup, because otherwise the cost, the time to implement it, time to train it, all of that could be much more than using any other technology. So if you can go next to the following slide, Peter, for me, I think this one is nothing new, right? Everybody knows about a challenge in the supply chain where, obviously there's simple objective, right? So buyer wants to actually pay as late as possible, but supplier wants to collect as early as possible. And that has been there for donkey's years. But what is happening in the traditional sense of world, that there are banks who come in and say, oh, here is my supply chain finance, you are a Unilever supplier, and here it is, the program you sign up, as long as you tell me you're a Unilever supplier, I give you some basis point off. And that's been traditional business, and there's a lot of leaky processes through the paperwork, through confirming you are a supplier, and then there is almost bank running as a boss to the supplier. So now in that example, can Unilever actually do it themselves, right? Taking the whole supplier ecosystem into their own hand, and their $10 to $12 billion of annual supply chain finance budget that they have, which they are giving it to 3 or 4 banks. Can they actually do it in a private permission environment where they could have a smart contracts running between themselves and suppliers putting their KYC information in there, and then actually get the banks to bid to make sure that they provide the best possible rate to their suppliers, and at the same time, at the risk of the anchor, they could actually continue to give them a better rate. So that's really what the challenges that exist in supply chain can be overcome with the distributed ledger technology. I think one more slide, Peter, for me, to really look at what you could do is, if you are a large enterprise today, you could quickly start your supplier finance program, and you could really get this ready go to market, which you could get to your tier 1 and tier 2 and tier 3 suppliers, and you could really get them into this platform by a way of telling them, look, in this world, I'm the big guy, I can support you. As long as you commit to me, I'm willing to support you to get you the best possible financing for you. And it provides all the authenticity and, the privacy and setting is related to your network. It also has, with the help of the logistic providers, which is another node within the network, it also provides performance and credit scoring for your suppliers. So this really this really means that there's a new business model that a large company could come about, where you could have a logistic provider, they could have the lending providers, and then their suppliers, all controlled through this network that has been built to really drive the financial resilience in a network. And then you have a classical solution like AR invoicing, AR/AP factoring, invoice discounting. It's been going on for ages. There has been no change in that. The reason there is no change in that because there was no technology which could actually provide an UI and the workflow and the time to market as quick as what distributed ledgers can do. So that's the platform that we have built. The last slide, if I still have a minute left, Peter, to really talk about DLT ledgers. So we are a Singapore headquarter, late stage blockchain company. We are the only company in Singapore which is making real dollars out of selling applications. And like my previous speaker said, that it's not about blockchain, it is about the business applications. So you could see the 16 different modules that has been built on top of the Hyperledger framework, which actually allows you to manifest these processes, and we can support different use cases, which actually are the real world use cases that really needs a solution today in a fastest possible time for you to get running and get started. And I agree that you actually don't need to wait for consortiums. Consortiums takes donkey years to get it going. It is about taking you as a large enterprise, taking your supply chain in your hand. And if you could actually now provide the master contract, the baby contract, the visibility, the consensus of documents, and also kind of provide them with some sort of KYC platform, which banks are comfortable looking at suppliers' information in this, I think that is a win-win. So that's probably is my last slide. I want to spend more time talking about this concept and talking about what this could mean in this world today to the large enterprise companies, specifically in FMCG world, automotive world, in the areas manufacturing, distribution, where we see this has the immediate applicability, and it actually works on top of the existing softwares like SAPs or Aribas or Coupas or Oracles or JD Edwards or whatever that they've got. It actually kind of provides a real inter-enterprise layer of application that one could work together with, and we are very excited to share this with this group. Peter,
Okay.
any questions?
Yes, thank you. So are there any questions for Atul?
I've got one.
Yep, go ahead.
Atul, this is great. I have to say, you're now the fourth speaker that made this conference worth actually staying for the whole thing. This was interesting, but could you tell us? I mean, when you say that it was easier, and to develop this on a DLT as opposed to a traditional system of record, can you say more about what attributes of the DLT made that easier?
Oh yeah, no, that's a great point, right? So I think it's about linking the contract species, which could be authenticated and validated independently. Is that John? Yeah. Yeah, it's about linking those contract pieces, which could be authenticated and validated independently. Secondly, it's also about what they actually would upload or what they would submit is actually clearly identified to themselves. And then because the audit trail and the lineage can be established without a doubt, without being one system admin, and because it's a shared distributed ledger with the consensus algorithm on top. And that is actually a key requirement that banks are looking at. So in order to get, if you were to cycle back here, right, you have to go back to the person who is going to fund the money. So who is funding the money? It's either the banks or an alternative guys. So there are already alternative guys who said that, okay, if you provide me this, I'm good with this, and that can only be done in a distributed ledger.
Who's got nodes, and why is this truly validated? I mean, if it's a small group, I'm pretty sure they can collude and change the record if they want. Why is this, and why couldn't you achieve the same thing with a traditional system and then state hashing it onto anything, the New York Times or a public blockchain like?
Yeah, no, that's a great point. So first, this is all applicable for the large enterprises who've got thousands of suppliers, right? So it is not going to be, five guys who are trying to do something together, right? So that's first point. You have a volume, you have the layer, and you have,
So every supplier is running a node.
It's up to the suppliers to decide if you could like if you say if you supply for a particular product, you could decide to have a node, because I think then it comes to about question of the cost versus benefit, right? So I think, yes, technically every supplier should have the node, but whether that makes financial sense is up to the business, up to the anchor here. And the second question about, why this could not be done in a centralized system, simply because, if you look at the world today, you have alternative finance providers who are willing to pay the money. If you give me an independent record of who has done what on each of the nodes, right? So which can only be done them joining as an observer node, and they are seeing how this is being run, right? So I think it is something that if it was so easy, it would have been done by Aribas or Coupas or others, the classical supply portal solutions who have been out there for years. But it's not that easy in the traditional sense of the world. And again, you can't establish your audit trail to the bankers or to the people, the lending companies who are going to lend the money. So I think it is the familiarity of lending companies to look at this as an independent, validated system, which I think helps to get this business case achieved. Otherwise, it's not possible in any centralized system.
Yeah, I think you'll have to take the conversation off to the Slack channel. Yeah, I think so. All right. So our next speaker is Preetam Rao, and from QuillTrace. Preetam, are you on the call?
Yes, hi, can you hear me?
Yes, we can. All right. So Preetam is the CEO and co-founder of QuillHash, which is a blockchain supply chain SaaS product. So over to you, Preetam.
Yes, hi, good morning from India. I'm Preetam, I'm co-founder of QuillTrace. QuillTrace is a blockchain-based supply chain SaaS platform. Please, next slide. Yeah. Okay. So in the supply chain, the problem that we identified is like there is lack of transparency between the supply chain ecosystem, and the supply chain ecosystem is currently very less efficient. Most of the work is on the paperwork, and the current supply chains are very less ethical and not sustainable. And nowadays everyone cares about the supply chain sustainability, environment. Yeah. Next slide, please. Yeah. The solution that we have currently working on is like a blockchain-based supply chain SaaS platform, where there would be real-time transparency for the multiple supply chain owners, and we are bringing more trust and efficiency in the supply chain using the smart contract-based automation system. And the supply chain, the product that we are working on is more customer focused. Like customer can scan the product and get the full traceability of any product. Yes, please, next slide. Yeah, the product features that we are currently building is our platform is, we are providing blockchain consortium, and our platform is blockchain agnostic. And we are also providing supply chain based templates for traceability currently. And we have and the next thing is you can add your products, or either you can upload your bulk products. And the fourth thing is that we are also building APIs and ERP connectors that you connect to your existing supply chain ERP system. And the next thing is we are also integrating the certification management in the platform. Yeah, next. Yeah, so this is our platform blockchain consortium UI. Here, you can create your consortium, you can invite your participants, and you can assign a role to the participants, like who's going to write the data, who's going to validate the data, and who can only view the data. You can invite your supply chain members, you can assign to roles to them, and you can ask the participants to upload their certificates for the KYC purpose. And you can kind of make a full proper supply chain mapping. You can see all the supply chain stakeholders. Next screen. Yeah, this is our consortium. Like currently we are offering Ethereum, Quorum and Hyperledger like blockchains. And also we are offering like without blockchain, you can create the consortium. Like in India, like we currently discuss with agriculture and organic supply chain companies. So they are looking for blockchain, but currently they want to, start with non-blockchain features with the, their supply chain members. And we are, providing, we also, tested on alternative blockchain. And yeah, that's it. Next screen. Next thing is the templates. The templates is a very important thing. Like you can dynamically create the attributes of your supply chain. Like you can define all the attributes, all the data type of attributes, and you can also define the input method of attributes. Like the input method should be manual, or it should be using any oracles, or it should be like, using any IoT sensor technologies. And the attribute should be public or private, and who can change the attribute, who can update the attribute, and who can view the attributes. The public attributes can be viewed by the end customer, like who is going to scan the product, so they can see the public attributes of any just assume any organic supply chain or anything. Private attributes, they can define who can see the attributes of one member can see these attributes, the second member can see these attributes. So you can create your supply chain workflow here. Yeah, next thing, next slide. Yeah, after creating the attributes, the smart contracts would be automatically created. Currently, we are offering the templates for the traceability. The smart contracts would be automatically created, and you can deploy the smart contracts to a consortium that you have created. Yeah, next. Yeah, this is the product history. Like user can scan the product and they can see the the product traceability, or any supply chain member can make the product counterfeited, and whenever like they are going to mark the product counterfeited, every member in the supply chain will get notification this product is counterfeited, and they can take the actions. Next screen. Yeah, this is the certification management. Like in the supply chain, you can like while adding the supply chain members, or after creating the accounts, the supply chain members can add their certificates. Like any kind of in India, you can add your organics. You are a organic supplier, anything. You can add your organic any kind of certificates, and you can manage your certificates. And like you can be part of multiple consortiums, so you can manage your multiple certificates here, and you can attach the certificate to like any consortium that is asking for the certifications. Next screen. This is the like ERP connectors or API that we are working on. The APIs can be connected to any other supply chain platform. And currently we are also working on the ERP connectors, how we can connect with SAP, Oracle, or Microsoft. Yeah, next screen. I think these are the features of our consortium. I think I already discussed with these features. Yeah, please next screen. Yeah, this is our team. I'm co-founder of QuillTrace. Radha is my co-founder, and Tarun is our like chief business officer.
Okay.
Yeah, next. Yeah, that's it. Yeah, that's it.
Yeah, thank you for your lightning talk. So are there some lightning questions? I see in the chat that John Wolpert has said, which hyperledger, Besu, Fabric, Sawtooth?
Fabric. Currently we are offering Fabric.
Okay, Fabric. Cool.
Yep.
All right, good to know. Are there any other questions?
Well, I have a quick one if no one else has one. I was just wondering, with the ability to add certifications like organic certification, what ability is there? And that applies not just to what you've presented, but something that I've been thinking through the presentations is, what's the ability there for auditing? So, how do I know that this certification is valid, that it's been acquired lawfully and, is not a counterfeit? So I'm thinking with any supply chain, at the times when we commit information about the supply chain, we also need to have certain checks and balances in place that sort of verifies the authenticity. I suppose like a bit of an audit.
Yeah, I got it. So like in the consortium, like you can also invite, any participants or any member. So any, certification company or any auditor can be part of that consortium. And like they are going to, verify these certifications are valid. Yeah.
Thank you. So you'll have the the sort of authorizing organization
Yes.
would be form part of the. That
Yes.
makes sense. Thank you.
Okay. Well, thank you very much for your talk, Preetam. And so please, everyone, continue the conversation with Preetam if you've got questions on the Slack channel. All right. Our next speaker is Bharadwaj. Bharadwaj is completing his master's at University of Queensland, and is presently working on private blockchain and privacy transactions in Hyperledger Besu Ethereum client as part of his thesis. He's an experienced smart contract developer and an Oracle certified Java engineer. So over to you, Bharadwaj. I believe you're on mute.
Good afternoon, everyone. I'm Bharadwaj. As I mentioned, I'm one of the postgrad students in the University of Queensland. Today we're gonna go through a proposal where we're gonna use the types of the blockchain in the creation of the pseudo decentralized network. Next slide, please. All right, let's see which consensus algorithm is going to use in our proposal. As you all know, the proof of work has its own big problems. It's slow. It has slow in making the blockchain, and it has a forking problem, and it's expensive, computationally expensive. Coming to the latest consensus algorithm, like the proof of authority, like the click. Even though it makes the blockchain way faster, it has the problem like forking problem. And the forking and the privacy doesn't go along with each other very well. So ultimately,
yeah, sorry to interrupt, but your audio is really clipping and breaking up. Do you have another microphone that you can use, maybe?
Is it fine now, or should I go slow? If I talk slow, is it fine? Hello?
Yeah, we can. So we can hear you, but it's distorted. If you don't have another microphone, let's just go through it, because I think we can hear. I can make it out, but it's just I think people have got to concentrate quite a lot.
Okay. All right. I'll try to explain a bit slower, so the audience might get me. So the IBTF2 has no forking problem. So this fits better. This consensus algorithm fits better in our proposal. So coming to the permission blockchain, the permission blockchain is, as you know, like the nodes will have the admin nodes and the admin accounts will have the capacity to whitelist or blacklist the other nodes and the accounts. Coming to the privacy, there is the latest feature, like the two nodes can share a consensus, can share a smart contract, which is absolutely secret to both nodes. The rest of the people cannot see what is the smart contract that's happening. However, the smart contract existence will be registered in the blockchain. The privacy and the permission are loosely coupled, so it's up to you to use the privacy or to drop it or to use the permission. We also have in the Hyperledger Besu Ethereum client, we have the smart contracts to make the permissioning possible. Like you can use the smart contracts to delete. You can use the smart contracts to whitelist or blacklist the nodes and the accounts. So the smart contract is also helps us in making the proposal possible. And we have the Ethereum client like Besu, which helps us in combining the privacy and the permission network. Next slide, please. Coming to our proposal, I propose a privacy-based and I propose a privacy-enabled permission network for the supply chain activities between the organizations that join. Let's see the setup, how it goes. So we need at least like 5. So in the proposal, we need at least like 5 nodes, or else like 5 companies coming together and 7 contracts deployed. Let's see what are those contracts that need to be deployed in order to get things done. So the first contract is the admin accounts contract. So in this contract, the elections are held for every 6 months or by another contract. So in this consortium, 1/5 of the accounts will win the elections and act as an admin account. So here, the accounts which has the majority of the votes and the existence is more than half of the creation of the blockchain will be promoted as an elected account. So coming to the admin nodes contract, so it is very similar to the admin account contract, but except it is for nodes. So the elections are held for every 6 months or by another contract, and the most honest nodes. And the existence of the node for more than half of the time of the blockchain and having the more votes is elected as an admin node. So the result of an election contract. So once elections are done, the whomsoever the nodes and the accounts have won the elections will be printed or at least updated in this results contract, so that the other accounts will know who is their leader. Coming to the control node strength contract, this contract will keep a track of all the companies, whether they're exceeding 20% of the nodes it has or not. It also sees whether it also keeps an eye on the request contract and the protest contract, whether they are functioning whether they are functioning normal or not. So coming to the metadata contract. So in this contract, it has the list of the companies and its nodes and the accounts that particular company is holding. So it's kind of a simple metadata. It's all the companies and its related accounts and nodes are listed here. The protest contract. So here, if any company thinks that their requests for whitelisting or else the blacklisting of the accounts or the nodes are not properly taken care of, they can go for the protest. So in the protest, if 1/3 of all the nodes are accepting the protest, then the new elections will be triggered. Coming to the request contract, it's simple. Once I'm a normal company, if it wants to whitelist its accounts or else the whitelist its nodes, it has to put a request in the request contract. So it will be dealt by the admin. Thank you.
Thank you. All right. Are there any questions? All right. I think I've got one. So you've said that for the admin nodes and admin accounts, there's elections held every 6 months. So how did you come up with 6 months? You know, what's the basis for 6 months? Because in some ways it feels very short, in other ways it feels forever. So is 6 months a good amount of time to do governance, or is it?
Our logic is, for example, if you see the way the admin accounts will elect, they have to exist in the blockchain for more than half of the time of its origin. Like that means they are, for example, the blockchain has started 5 years ago. That account's existence should be more than 2.5 years. And secondly, it should not have any malicious background. For example, the account should be an honest account. So we believe such an account would not really deal something. In the practicality, we don't think such an account would act any maliciously. So we believe that there won't be any problem So we don't want the power to be exchanging in between the accounts very frequently in such a way that some very bad account or else a bad actor will get the control of. So we get the 6 months. So if it is shorter, the probability, this is a permission blockchain. So there is some form of a trustworthiness in the other companies that join. So with that in mind, so I thought 6 months would be fair enough.
Okay, well, yeah, that makes sense. Anyway, look, everyone, to continue the conversation with Bharadwaj, I suggest you please go over to the Slack channel and please engage over there. Right, thank you very much.
Yeah, thank you.
All right, our next speaker is Lindy Chen. So Lindy is the founder and managing director of Frethan Blockchain, as well as China Direct Sourcing. So she's got more than 20 years of international trade, and she helps companies import products from China to Australia, and essentially greases the wheel, as it were, makes it easier, makes things happen better. So Lindy, are you on the call?
Can you hear me?
Yes, we can hear you.
Can you hear
All
me?
right.
Oh, wonderful. Great.
Yeah. Okay, over to you, Lindy.
Thank you. Today is such a great opportunity and a pleasure to share Frethan blockchain deployment. Next, please. The Frethan is the zero for international trade. It's a complete Chinese supplier management solution with trusted legal certificate storage platform based on blockchain technology. Next, please. Here is a little bit of background about myself. Not only I started the China Direct Sourcing, China Direct Investment, and also I'm the president of the Australian Blockchain Alliance, president of Central Bank Chamber of Commerce, and being a mentor for more than 800 businesses. Thank you. Next. So here's the story. We have an Australian company who received a container load of sandbag, and when they actually ordered $80,000 worth of copper wire on Alibaba. And this is a very sad story. Next, please. This is quite common in internet era. And there is a fraud from both the seller and the buyer, and it's a cost and the time of completing the international transaction. And this is one of the problem exists in our international trade industry. And there is a lack of trust. And also often there is counterfeit products and information. Next, please. So we have designed some solution to solve that particular problem. Next, Peter. Next, China Direct Sourcing is actually an Australia leading sourcing firm. We helping business importing products from China. If it's $1 in China, you pay $1 directly to the supplier. You pay a separate fees for service. Next. We have designed 3 stages of importing process: research and tender, sampling, purchase the negotiation, production and delivery management. We believe in system and not the luck. So therefore we use system to overcome the shortcoming. Next. However, there is a limitation of our current solution. Because we are centralized solution, relies on well-trained China Direct team member, both in China and Australia. We can only service limited customer a year and take a lot of effort to facilitate one transaction. The cost of our service is ranging around 3K to 10K per project due to the labor intensive, and there is a repeated documentation. Only certain customers can afford our services, even though I have written a book and made a DVD about the process. Next, Peter, please. So we have designed a solution with the blockchain. And now I want to share with you the solution with blockchain with 3 case studies. Next one. The solution with blockchain international trade, they are trade lanes. Trade lanes project is designed by IBM and Malik, and they are more of a digitalization of the shipping. Another one is called the trade community system, and that is designed by PwC and the Brisbane Port, and they focus on more of like docking, like on the port. Next one is the Frethan, which is designed by China Direct Sourcing. We focus on the front end of the supplier assurance. Next. So our solution is use authentic identity, identified operation, authentic process, and traceable results, combine all the nature of the blockchain, design a complete Chinese supplier management solution with trusted legal certificate storage platform based on blockchain technology. Not only that, we also tapped into Chinese legal system, their database, and also their structure, and designed according to the China electronic law system as well. Next. So our solution is revolutionary the international trade system based on our 20 years of international trading experience success and powered by the latest exciting blockchain technology, have an award-winning team of incredibly experienced trading experts with solid contacts and trusted relationship, have a vision of global domination. The goal is to trade in every market in the world and have the financial backing and the large database, probably more than 30,000 suppliers, and a robust long-term business plan in place. Next, Peter, please. So this is our Frethan, how that look like. As you can see, this is our front end. It's international and local trade, and our design, the front page. Next. This is the supplier, like a buyer's dashboard. As you can see, we mentioned about the 3 stages, and now it's everything digitalized and platformed for our client. And before they only managing by us with the consulting services, and now we all supplied on a dashboard. Next. And you can see as a buyer, you can choose, what sort of product you are still importing, what sort of project is ongoing, and who is the supplier, and have the supplier managed it and certified, etc., etc. Next. And this is the app, like the buyer's dashboard in like a mobile phone. Yeah, next. Next. And we have the opportunity, even if we just have 1% of the market, 2.4 billion.
I think we just lost Lindy. No.
Yeah.
On an online conference, it was gonna happen. Let's think about what to do at this moment.
But it did sound like her audio was starting to go and she was freezing. So I think she probably, hopefully Lindy would come back. Yeah.
Okay, brilliant.
All right. So yeah, basically that's the market size. The next one, please, Peter. Yeah, as you can see, we have designed a membership model similar like the way how Zero growth internationally, and we have ambitious goal as well. This is very conservative and projection. Next. Our key difference is, have 15 years experience in the international trade, prevention of the fraud, creating trust via the system. And we focus on the Chinese supplier, high quality control, selecting and managing the Chinese supplier. And Frethan is the international trade certificate storage platform, supporting the development of the international trade. Next, Peter. Our go-to-market strategy is complement, not compete with the large e-commerce company like Alibaba or Amazon. We are software targeted at the front end of international trade, the supply assurance, and the leverage 15 years of China direct import expertise as a competitive edge. Our price point is very affordable, and we launch with existing authenticated China supplier database, probably 30,000 supplier. Yep. Next one, please. Here are some of our completed milestones. We are very lucky. We secured some Chinese government funding. We are now on the second stage of Australian government, the federal, they call the accelerating commercialization grant of $1 million. So we are very, very lucky at this moment, and we're progressing quite well. Next, Peter. At this stage, we has adopted in 16 provinces in China, and also we received both Chinese government and Australian government support. Thank you. Next one. What's next? Our next is complete our product demo to public within next 6 months. We anticipate this platform will be ready to use as an initial stage to take the customer and for the buyer, for the seller, and start to go through the business flow. Next. Here are the 6 stages of our development for the next 5 years. We're looking at not only just having the Chinese supplier export products to Australia, we also can export Australian products back to China, and also China to other countries such as UK, New Zealand, USA, and as well as Australian products to other countries. So it's going to be real international trade with different stages. So that's basically it. And the next slide, Peter. Thank you very much. And this is my contact details. If anyone interested or have any question, please feel free to ask me about anything international trade, about Frethan, about the opportunity, about the supply chain, about China. Thank you.
Thank you, Lindy. It sounds very exciting, very exciting.
Yes, it is. It is.
So are there any questions for Lindy? I've got one. So we've had this posed by a few people today, but so you've got a blockchain system. Who hosts the nodes in the blockchain? Who do you see hosting the node in the, or actually, no, I'll ask a question before that question. So is the Frethan coin, is it a ERC20 token on Ethereum, or is it a completely separate blockchain?
Okay, so 2 questions. First of all, the nodes. Originally, the nodes are only held by a few of our key partners. So such as, there is one in China and also who developed the whole system, as well as our here, and also our logistic partner. And so along the way, and that's how we see, so far we have identified the 5 nodes. Okay, so another one is Frethan. We have already issued our token that's based on ERC20. It's called FAE. However, once the Frethan, the platform is fully operational, what will happen is we will actually destroy the ERC20 token and use our own token, like our token on our own chain. Yes.
Okay. All right. Well, that's good. All right. Well, thank you again. And please, everyone, continue the conversation on the Slack channel with Lindy. I'm sure she'll be happy to answer your questions. So,
thank you, Peter, for the opportunity.
Not a problem at all. It was great to have you on.
For use case of the blockchain and implementation in a cross-border beef supply chain, and to suggest and consumer trust and confidence. This work is a part of our joint project, export smart contract, which is collaborated between University of Queensland University of Technology, Food Agility, and also the Beef Ledger. So, and before I start, and let's have a quick look at what I'm going to share with you. So the first, and we will look at the introduction and the context, and then to see and the meat and authenticity and traceability in China. And after that, we will show and use some blockchain and the application or the use case in the food and traceability. And after this is followed by our initial design and the protocol for the blockchain enabled traceability system, and for an Australia and the beef supply chain. And then we try to consider the consumer feedback. So we do the empirical test with the Chinese consumers. So including the voice of the consumers, and in design, we design the new features, the human machine and reconcile. That is, we reconcile human and machine intelligence to stress consumer trust in the next round. And finally, I will wrap with the ongoing research. So for Australia beef industry is a very big important agriculture industry and in Australia, and also for Australia's export to China, see a very significant increase and over the past years. So in the last year, so China became Australia's the top one and destination market, absorbing almost 25% of all Australia beef export. And in addition to that, China is also an attractive market for premium Australia beef products, and giving it a willingness to pay more compared with other leading export markets like Japan or the USA. So although China is a very premium market and also as Australia suppliers can see, but we should be aware that China is also a market with frequently reported footfall. So because of the occurrence of the footfall in China, the consumer have low and lower trust in the local food authorities. And even when they come to buy imported meat products, they also try to search for extra attributes to indicate this is the true and authentic products they buy. But the problem is that because Australia beef products is perceived as a premium product in the Chinese market, so there is a high counterfeiting risks. And according to the to our research in PwC, and they estimated that half of Australia beef sold in China isn't Australia beef. So this is very horrible figures. So considering the footfall in China, so where to buy authentic meat products in China. So in the last couple of years, and there are some new concept store and even some boutique and specialty supermarkets have been emerged in China. So for this and the stores, there's no equivalent in the Western market. This is mainly in the Chinese market. So they try to provide some, and they see the quality products to some, and discerning customers. And also, and for some and store, they provide very detailed and labels. For example, like the one you see in the middle, they provided the English name and also Chinese name, and to show where the originally from, and also where it is and reprocessed in China, to give more details to try to convince the consumer this is the true and the authentic products. So the question is that is the authenticity guaranteed? But not really. There are reported cases in China for like the Hema Fresh, which is owned by Alibaba, and for some store, and they changed the the product labels, and also there people that can see there are some products from the green channel, and are sold in this supermarket, with the force field and the certificate. So for the traceability of Australian beef in China, at the moment there are a couple of ways. The first one is the ML is country of the labels, and this is a very simple label put on the meat to show that it's a true Aussie beef. And besides that, there are QR code and traceability, or like the one you see. So people using their mobile phone to scan, and so they can go to access to the protocol, where the consumer can see the certificate, and also there's some documents. So the problem is that if this data is people can I believe this data? So this is also a big problem. So for the we look at the traceability issue and also the rising appeals. And at the moment, for the traceability technology and application in China, they normally provide the QR code for the anti and counterfeiting presentation. But most the links, when consumers scan, they link to the website or buying channel, or even to the one I mentioned before. So there is a big issue about the information authenticity. So from the consumer side, and they are unable to get the information and they want, and there are also too much information. So it's very difficult for them to quickly find the critical information. So, and also after the outbreak of the COVID-19 in China, and the consumers, they have very increasing awareness of food safety, and they want to need more and traceabilities. And also for the retailers in China, they also call for the responsible traceability from the upstream, because when there's a food fraud and happened, the consumers and put their finger and to the retailers or the buyers, the nearest buyer. So, and also for the consumer side, they want the carefree consumption, and also there are some appealing from Australia side in the brand protections. So the core need for the traceability is the trust and the confidence. So how we can build the confidence and the trust. So blockchain, because it is regarded as the decentralized and mechanism, so this can provide the trust proof. So for the blockchain and the technology have been used in the food and supply chain, and currently for most of the applications is mainly driven by the leading retailers, such as the Walmart and the Carrefour. And also the same case in China, for example, like the two big and leading giants in China, like the JD.com or Alibaba, they are trying to initiate the blockchain issue for the traceability of Australia and beef products. With the current data, we can see that for the blockchain traceability, it can really increase value to the supply chain, and also for the retailers in China. For example, it's reported that for the blockchain traceability and for live streaming can increase and sales by almost 80%. So the question is, because all the blockchain solutions driven by the downstream actors and also the value adding from the retailer side how producer can participate and share the value adding is rarely addressed at the moment. So in this case, we are trying to develop a blockchain-enabled food traceability system to help Australia and beef producer and also the processors and to fetch the value in the Chinese market. So we designed the 4 levels of the blockchain and the supply chain and the process, and also ending the consumer and experience. So we have the the physical supply chain and using the digitalized supply chain, and then using the Internet of Things and also the remote sensing to collect the data to the blockchain. And also for the blockchain and the user case, we focus on the 2 types of Australia-China supply chain. So we look at the quarter cart, this is the the big cart, and then to do processing for the small cart in China. And also another, we look at the Australia cart and package and beef export, the small package. So starting in December 2018, the beef lodger engaged with a beef producer in South Australia and also Ottawa in the North and South and Wales to try direct export of a blockchain credentialized beef products in China. So, and this is the initial and the prototype we have. So for from the consumer and they can scan and on the top left you can see this is the fingerprint. They can using their and WeChat and mini program to scan that, and then to access to the blockchain verified text and also the information chain. More importantly, we have 1 minute and short videos, and because in recent years, Chinese consumers prefer to the information delivery and from the short video and over and the traditional text or messages. And besides that, we also conduct offline and showcase, and in China in the November last year, we try to hear the voice of the consumers to see and their feedback to our design and prototype. So for the empirical and the testing of the use case, and we conducted a survey in China. For the survey, we try to capture the Chinese the impact of our user prototype on the consumer trust and the confidence, and also the meat quality. And besides that, we also to see how the consumer's willingness to pay, and also for the willingness to pay extra for the blockchain and credentialized traceability information. So this is for this empirical test, it is part of the survey. So we try to see and how and the blockchain solution that can impact the consumers and the perception over the Australia cart and the packed label, and also the traceability trust, and also the quality perception for the Australia beef products produced in Australia or produced in the Chinese and the market. To define the the feedback. So we divided our responding into 2 groups, and the control group and also the treatment group. So for the because as I mentioned before, for Chinese consumers prefer the short video for the information delivery. So we mainly focus on the short videos. So we have the treatment group watch the short video and then answer the questions. And also with the control group, they didn't watch the video and did directly answer the questions. So this is the empirical and the test of the short video prototype. So for our respondents, we have the local and residents, and also the foreign residents. So the result generally shows that so our blockchain solution can increase consumer trust, and for the they can increase their trust in the label and also trust in the traceability, and also with the blockchain and deployed along the supply chain, this can also impact the consumers and quality perceptions. and for example, mainly and the Chinese consumer, they think of highly of the Australia processed and the cut and processed beef products and over the Chinese processed. With the blockchain deployment along the supply chain, consumers can increase their trust over the Chinese processed. But although there are trust in the consumer and from the consumer perspective, but the trust is not very significant. So we try to, so then we have a focus group discussion with some and the consumers to hear their feedback to see and why and they have not significant and impact, and also what's the next step for the design to suggest the suggesting and their trust. So after discussing with our and the supply chain stakeholders, we proposed a new feature, the human machine and reconcile and the mechanism. So you can see this is the conceptual framework, and we have the multi-sig responsibility and the mechanism, and also all the events tracked on the blockchain system. So consumers and they can search the traceable information and also verify the information. And also another thing that we reconcile human and the machine reconcile, and using the consumer software to generate the data and with the human and the interventions. So this is the shows and how and it works, and we have the multi-thing and the mechanism. So for example, with the data we collect from the the sensor or the Internet of Things, and they come on the blockchain system. So then we have the other and the supply chain stakeholder as the witness. So when the data created, the data and it's linked to the previous and the data queue, and also the data is witnessed or verified by other stakeholders to improve and the data and the integrity. So this diagram shows and you how and we deploy this human machine reconcile mechanism from the chain-wide and operational mechanisms. So we link the chain from the end to end. And also, so you can see that for each and stakeholders, they and using the RFID scanner and to scan and to scan the data, and also using the human input. Here we have the digital identity for each and information input or verifiers, and also for the data, it's the data block is linked with the previous and data block for the data and integrity. So we have the nested data, and also for the human and the intervention data. For the data, we have the human intervention data and the data from the sensor or the RFID tags. And from the consumer side, the consumer can query the data. So this, for the interfirm and operations, normally, from supply chain from the perspective, it's often regarded as a black box. So we try to, to gain more trust. We try to open the black box. So here and you see and why we also using the human machine reconcile mechanism to visualize and transparent the operation, the interoperationals. So we engage internally to ensure the implementation of internal and practice, and also the process, the processes. So, and based on what we have proposed, the new features, we designed the procedures of the beef ledger system built and on the Ethereum. So generally, and we have the 7 steps. And as you see, and on the left-hand side and on the right-hand side, you can see that on our the Ethereum and the system, you can see and for the data, and we can see the data is verified. So this is the user fees for the supply chain stakeholder. They can see which data is properly stored and which data is verified, and also for some data the verification field. So, and for our ongoing and research, we try at the moment for our and deployment, we mainly include some innovative businesses and who strategically aiming to establish fast mover and advantages. So next step, we will try to get more stakeholders involved in the whole beef export the systems. So another step is we are working with the other external and authorities like the export and authorities, and try to provide some external verifications. And also we try to because the consumer is the most important side, the link in the supply chain, we try to get the verification from the consumer side to have the consumer see and into the systems. Yeah, I think I'll stop here.
Well, thank you for that great talk, Shoufeng. Are there any questions? All right, well, I think I've got a question. I'll turn my video on. I think I've got a question, so which is perhaps not directly related, but so at the moment, China has put bans on importing Australian beef, if I understand. Yes. Do you think, so is there a way, do you think, that using the digital ledger or distributed ledger, the blockchain, will be able to say, look, it's got greater assurance. So, because I think they were trying to say there were quality issues or something. And so, I mean, to try and prove beyond doubt that it's a baseless claim, yeah, maybe could blockchain be used, or what are your thoughts?
Yeah, I'm thinking, for example, like the supply chain, and we want the transparency and also the visibilities. And for we try to working with the Chinese, the local authority to work on much more and open and transparent supply chain for for the deployment of the blockchain. And probably you have heard that China is very aggressively and launching a new and national blockchain and service systems. So we are so that I think can provide much more and visible data to show for example, like you mentioned, we see the quality issue or something. So when all the supply chain the transparency is provided, so that can give you more sense of what is really happening.
Okay. Are there any other questions? Okay. All right. Well, let's thank you.
Thank you, Pete.
And if you people, please continue the conversation on the Slack channel. So yeah. All right. Thank you. Okay. So our next speaker is Sidra Malik. And so Sidra, thank you for joining us today. So Sidra is a PhD student at the School of Computer Science and Engineering at University of New South Wales, which is in Sydney in Australia. She is supported by Data 61 CSIRO for her program. And she's doing a thesis entitled Blockchain in Supply Chain Management. Her research work focuses on providing solutions regarding traceability, trust, and privacy for blockchain-enabled supply chains. And she's also got a Master's of MS, so Master of Science in Information Security, and has been working as a lecturer and a software quality assurance engineer for more than 5 years. So Sidra, I've got your slides here and I'll share them if you like.
Yes, please, Peter. Thank you.
All right. So I'll tab to the right application, share. No, let's share the slides, and then and these are your new slides, so or your updated slides. So we're all good.
Okay.
All right. Take it away, please.
Thank you, Peter. Hi, everyone. So this talk would be more probably on the blockchain technology usage in its right way and what blockchain can solve technically and where do we need some more mechanisms to use this technology to its full potential. So my talk will be divided into 3 parts. In the first part, I will briefly discuss our framework for the provenance and governance and scalability in supply chains. In the second part, I will talk about trust chain, which is a reputation management layer on top of our previous blockchain solution. And in the third part, I will focus on our current work on the privacy and control in supply chains. Next slide, please. So with the previous talks, it's quite obvious that with an increased incidence of food mislabeling, for example, and counterfeited products and handling in recent years has led all of us as consumers to demand more transparency in how food items are produced or handled. And the current traceability solutions suffer from issues such as scattering of information across multiple silos. And in order to remove any sort of doubts regarding erroneous data, and we are able to use the blockchain in order to produce farm to fork stories so that we have exact location of where our foods are sourced from, and what is the traceability and history of our product that we are using as a consumer or buyer. Next slide, please. So as we all know that blockchain provides us with integrity, immutability, and availability. And due to these features, we can solve many of the problems with within supply chain industry. However, the adoption of blockchain itself is not straightforward, and it requires some careful considerations. Next slide, please. So this is where I summarize that what are the major problems within the areas such as provenance, trust, quality, and privacy. So if we take provenance, for example, in order to have a holistic model, the provenance can only be provided if there are proper governance of rules and we have everybody agreed to those rules. Then for the enforcement of rules, we need some governance from an external third party, or we need some access control mechanisms. Not only this, we also need to have some scalability mechanisms because supply chain is a high volume system. And when we are generating such a huge amount of data, blockchain systems cannot promise to be scalable enough. And the second problem is that when we are putting that data which refers to the provenance or traceability on blockchain, there might be a data which is not correct at all, and it is the erroneous or a faulty data due to the misconduct or dishonesty of the participants which are contributing the data. So in that case, what blockchain is doing is that it is just putting a log or a hash of a data, which is a faulty data itself, on the blockchain. So the immutability is certified, but the data reliability is not. So in order to promote the reliability, we need to have some accountability mechanisms. For example, some sort of penalties and incentives in order to have the participants contribute the honest data to the blockchain. Then the third part, consider that there are, where there is a availability of data or data observations is limited, such as there might be situations where there is an unreliable IoT data. How can we ensure the quality of supply chain products? And we need a mechanism which is required to prevent any malicious behaviors on the part of supply chain agents. and which can ensure that supply chain, the supplied produce or the products are of high quality. And in the end, I would say that given everything, there are still lots of obstacles in adopting this technology as in supply chain. Why? Because not many of these things are known to the counter supply chain participants, like the many details regarding to trust, provenance, quality. All these things are the trade secrets to many supply chain vendors, and they do not want to share the data in first place. So they have every right to own their data, and in order to do so, we need to protect their privacy and provide some mechanisms to ensure their data is not there on blockchain to be seen by other competitors. So I will head on to the individual solutions. Next slide, please. So this, in this part, we address the provenance, scalability, and governance. This is a published work, and it is named as Product Chain. It is a blockchain maintained by the consortium of supply chain participants, and it's used to improve the traceability by providing an immutable audit trail of data associated with the supply chain goods and events, and by making otherwise siloed data available to all the authorized participants. And next slide, please. So what I have is here that we propose this permission blockchain framework, which is governed by a consortium of key supply chain entities, including government, regulatory bodies, and blockchain vendors. And they form this governing board, which formalizes these consortium rules. And once the control list is devised based on these rules. So the access control list is what basically decides that nobody in the system is able to control the data which is written or read from the blockchain. So once we have these access control rules provided, we have a permission ledger where where the participants of the systems, which are the registered entities, can write to the ledger, and the non-participant entities can access to that ledger, again under the accessibility rules. Next slide, please. Next, what we define for this is network architecture. So we propose that in order to deal with the scalability of supply chains, we propose this sharded network in which we have multiple side chains which are operating in parallel and in different regions, geographical regions, I mean. So in each region, the blockchain participants, or the supply chain participants, sorry, they would record their information or the key data regarding to the provenance or traceability in that side chain. And in the end, the data from all the side chains is consolidated into a one single product ledger. I'll come to this using an example later. Next slide, please. And then in order to do so, what we create is a transaction vocabulary, which replicates a trade event in a physical supply chain world to a blockchain. So in this slide, as you can see, that we have one create transaction, which basically replicates the existence of one produce or basically on the ledger. And then if we have a trade in a physical supply chain world, that is being logged as a transfer transaction onto the ledger. And then a produce transaction is very specific to a manufacturing unit, which when, for example, produces a final product, it then involves all the create and transfer transactions involved in the production of that produce, for example. And one can map from the produce transaction back to the other transactions. And in the end, we have the final product on the retailer shelf. Next slide, please. I would pass this slide, next slide, please. So just keeping the connection to previous create, produce, and transfer transactions, here is an example of what product chain is capable of doing. So we have this, for example, a chocolate, dairy chocolate on the shelf, and we want to determine the provenance of two key ingredients. One is cocoa, and then other is the dairy, for example. Here, if we want to, so how the traceability works is with that we scan the QR code, and all the, here the blocks in the dark blue are the trade transactions. The one in the purple these are the create transactions, which are the initial registration of the produce. And this one in the sea green is the produce transactions. So in the first step, we kind of trace the QR code, and we are led back from 1 to 3 to the produce transaction, which is the manufacturer's transaction. And it tells us that this produce with this barcode, for example, was sourced from this and this key ingredient. And from 4, we fork back to the individual ingredients itself. So we can have like a product ledger for one product on the shelf. So next slide, please. So for some performance results regarding this system, we have validating transaction. We have a baseline system where we do not perform this product ledger, and we have a current traceability time. And with blockchain validation, we have an overhead, which is just a little more with the trade transaction. And with the side chains, with multiple side chains, we see that the time with the, though it is increasing, but it is still acceptable for a traceability measure on blockchain. Next slide, please. So now we come to how we ensure the reliability of data associated with the product lifecycle and supply chain events. So product chain provides a tamper-proof audit trail of provenance, supply chain events, and scalable network, but it does not solve the trust problem associated with the data logged onto the blockchain. If the supply chain entities generate the false data, it becomes immutable when it's on blockchain. Next slide. So here we propose a 3-layer architecture, which we call trust chain, is based on the previous model as product chain, and tracks interactions amongst supply chain participants and dynamically assigns trust and reputation scores based on these interactions. And what we do is that we have the model, which is granular. It has multi-source observations. And we have accountability and reward mechanisms to penalize and incentivize dishonest and trustworthy participants, respectively. And we also show that we have a less computational overhead within our existing system as product chain. Next slide, please. So I'll go to the data layer first. So the data layer has the input from sensor data, trade events, and the regulatory endorsements. I'll more show please go on to the next slide. So the trustworthiness of the entities are based, as I said, based on the multiple observations. We have, for example, in food storage, where we have our temperature controlled shipments throughout a journey of a food item. We have regulatory endorsements for just like we do it for any organic production site, we would do for any storage site as well. And we have a periodic assessment of the storage site, and a regulator would approve that if all the safety measures were being met or not. And then we have whenever two parties are having a trade between themselves and they have a trade event, those trade events based on their satisfactory level have an output as well. And then we have some sensors which are always associated with the Proteus, which are continuously monitoring the temperature levels, for example, throughout its journey. So based on these three inputs, what we do is that we put a reputation model. Next slide, please. Along with the blockchain, on the blockchain layer. So we have the transactions generated from our data layer, and those transactions from these three observations would contribute to the reputation and trust model here. Next slide, please. So if you see that we have one quality contract, here we devise the smart contracts. One is the quality contract and one is the rating contract. So the quality contract is supposed to monitor the quality of the trading produce along its journey. And the rating contract, on the other hand, based from the three input observations, it basically devises the seller's reputation score. Next slide, please. So if we go to the reputation and trust module, so the commodities reputation is acquired from the log of the sensor data that we receive periodically. And seller's reputation, we have this model which computes the instantaneous seller reputation from the three observations. And then we aggregate this information over the time and multiply it with the forgetting factor just to replicate that the recent transactions, the transactions or the reputations in the recent time have a greater impact than the transactions which were long in the time, long before in the time. Next slide, please. So based on the reputation scores, we kind of, we devise the overall trust score for a trader to participate in a blockchain-enabled supply chain network. And based on the trust and other features, for example, the number of successful transactions or any other we can think of, in terms of our use case, we can apply here. And we have the overall trust score. Also, if this trust score is greater than the minimum required trust score to take part in the network, then the supply chain party is allowed to store data and to access the data. Otherwise, the access is revoked. Next slide, please. So here, I've kind of already outlined these penalties and rewards, but what we do is that we provide on the application level the queries with the data and the trust and reputation scores of the parties. We apply rewards by publishing the highest ratings, and we also provide the penalties by revocation from the network. Next slide, please. So there are some of the attacks which are possible, like we don't deal with the sensor tampering and sensor modification attacks, and where there is a possibility of dishonest traders colluding with other traders in order to get high reputation scores. And so most of the collusion with the bad mouthing and ballot stuffing are possible, and the sensor tampering as well. Next slide, please. So here we kind of summarize our work with terms of latency and throughput, and we see that trust chain latency is a little higher than the baseline system, but it's still it does not cause that much overhead to have a reputation system involved. Next slide, please. And here is another comparison for the create transaction. Just pass through this. Next slide, please. So this, now I'll just briefly summarize our two current works. One is which are unpublished at the moment. So one is the quality control. Trust chain assumes that the IoT sensor data contributing to trust management system is not tampered with. However, if IoT devices may well be manipulated by device owners and or other malicious agents for any monetary gain. So in the absence of reliable IoT data, a mediator is required to resolve any quality disputes between the trading parties. So the actual quality of the goods cannot still be determined without involving a mediator. And when we do so, we have a very high cost associated and also the time consumption. The next slide, please. So what we are currently doing is that we propose a blockchain-based quality control mechanism, which is based on game theoretic approach. Our solution defines a quality-based price and penalty mechanism where agents are incentivized for supplying high quality goods, and dishonest behavior is countered through monetary penalties, and they are enforced by a mediator. And we also have a high overhead and added cost for dishonest behavior. And this is in short. So this is one of the current works ongoing. And next slide, please. So the other work that we are doing is, despite traceability and trust solutions such as product chain and trust chain, the supply chain big players are reluctant to fully adopt the technology. So next slide. So this is the last slide. And here I would say that what we are offering is by providing a trader or the supply chain participants with the choice of not sharing the private data. And for doing so, we are saying that as John said, that we can have instead proof of secret information on the blockchain. And we are doing so by using the zero knowledge proofs, and anyone can verify these secret information. And in this way, the actual data will never be shared on the blockchain, and traceability can still be provided, and the other benefits of the blockchain technology can still be achieved. Thank you. I'll just wrap up here. Up to time, I think.
Yeah. Well, we have a few questions in the chat channel, so I'll read them out. So, what information is included in your product ledger? And then I think then how do you test the query time against product ledger size? And have you had some products on your ledger? So I think what information is included in your ledger is the first.
So this was the permission ledger. So I think initially what we had, since it was traceability, so basically what we had was the origin information. And then the trade from so since it was a permission blockchain, so already there were the registered participants. So we only disclosed such information inside the permission ledger was the origin of the produce itself and the trading bodies. So which we assume that inside a permission blockchain, it was fairly safe to disclose. But in the end, as I concluded my talk, I've said that many of these, and also these, the trade flow that you saw as in product ledger is only limited to the blockchain provider itself. So it's not shown to the consumer when the queries are being made. And in the end, as I said, that blockchain privacy preserving mechanisms, we are ensuring that those trade flows are never exposed and the blockchain data is not shared in the first place, not even the provenance data.
Mm-hmm. A question we've had from two people was, how close is this into production? So are people using this for real, or is it still just a prototype system? Or
It's a prototype system, I would say, because it's just a part of, right now, I mean, every trust chain, product chain, are private key and control mechanisms. So they are the prototype systems and proof of concept being made. So they haven't been, outsourced or gone to the production level yet.
For sure, understood. Sly, you've got a question, and rather than me trying to work through your question, maybe you should ask it yourself.
Yeah, I was just gonna, I saw there's a lot on reputation stuff, and good you analyze different attack vectors and stuff. For the actual product chain in terms of provenance and the create/trade/produce transactions, do they track volume? Like if you produced 1,000 kilos of cocoa, yes, the bar can say it's that producer, but does it track that they didn't use 2,000 kilos of ingredients or something?
Yeah, I think that is really up to the producer. I mean, whoever is consuming how much of those raw material into the production. So it has to be defined inside the produce transaction somewhere. So, and which can be kept private, but not disclosed to the external bodies. But I think there should be some, you can read more on in the paper where I think I mentioned that we can have, so we don't exactly touch the volume itself, but I think that can be encapsulated in the produce transaction more precisely, where we can actually define that how much of this raw material was used.
Is there a link? Is there a link to the
I'll
paper or something?
Yeah, you can probably for the paper.
Or you just talked about So
yeah,
you talked about an actual paper.
Yeah, it's just the product chain. Yeah.
Okay, yeah, I found it there, I think.